Hi everyone, my name is Sai Charan. I am from Computer Science Engineering Data Science Department. AI, Artificial Intelligence, topic self-adaptive intelligent agents. Introduction to self-adaptive systems. It means self-adaptive systems autonomously modify their behavior in response to environmental changes or internal state shifts to maintain performance objectives. These systems imply feedback control loops. Example map monitor, analyze, plan, execute over a knowledge base to enable runtime application. Key properties include self-configuration, self-healing, self-optimization, and self-protection, collectively known as self-properties. It means self-adaptive intelligence agents are autonomous software entities designed to monitor their environment, evaluate their performance, and autonomously modify their own behavior, structure, or parameters to meet goals in changing or uncertain environments. These agents are essential for systems that operate in unpredictable context. Example IoT, robotics, cyber security, where static pre-programmed instructions are insufficient. Adaptation is driven by goals defined to design, time, or learned at running time using reinforcement learning or utility functions. Applications span autonomous vehicles, smart grids, robotic swarms, or cloud infrastructures requiring resilience and scalability. Intelligent agents core concepts. An intelligent agent perceives its environment via sensors and acts upon it using actuators to achieve designated goals. It means to pursue environment, to adapt environment, and via their reactions due to sensors characterized by autonomy, reactivity, proactiveness, and social ability, enabling interaction in multi-agent environments. Rational agents maximize expected utility by selecting actions that optimize a performance measure given available passives. Agent architectures include reactive example, subsumption example BDI and hybrid models combining planning and learning. Believe design intention BDI means models formalize agent reasoning using model logic. Beliefs represent knowledge, desires, goals, and intentions committed plans. It means core principles of ESC in the diagram self-adaptation versus traditional control systems. This diagram intelligent agent structure. This is an agent. It is an agent structure. This environment. This agent structure passive environments through via sensors, percepts, actions, effectors. Architectural frameworks for self-adaptive agents. Core principle and architecture. Self-adaptive agents are generally built around closed-loop feedback mechanisms, commonly referred to as MAPK monitor analyze loops. Monitor. The agent collects data from its environment and its own internal state is called monitor. Analyze. The agent evaluates the data to determine if the current behavior meets performance goals or adaptation is needed. Plan. The agent formulates a strategy to adapt its behavior or structure. Execute. The agent implements the planned changes. Knowledge. A shared containing models, logs, and rules that guide entire process. In the three-layer architecture, separate functional application, control, adaptation logic, perception, and state estimation. Decision making under uncertainty. Markov decision process, MDPS. Model sequential decision making with states, actions, transition probabilities, and reward functions. V of S equal to maximum R of S comma A plus gamma of P of S comma A into V of S dash. This is partially observable MDPS, extend MDPS by incorporating value states, overriding, increasing realism, uncertainty, learning mechanisms in and goal reasoning and planning. Goal reasoning, maintaining and abounding goals based on changing context, priorities, and resource constraints. Hierarchical task networks (HTNs) decompose high-level goals to executable subtasks using domain-specific methods and ordering constraints. Partial order planning (POP) constructs flexible plans by ordering only necessary actions, enabling dynamic replanning under uncertainty. Temporal planning incorporates time constants using models like timed automata or simple temporal networks for scheduling. Goal-driven autonomy GDA frameworks integrate goal formulation, explanation, planning to enable proactive behavior in open worlds. Runtime verification. Runtime verification and assurance. Runtime verification monitors systems execution against formal specifications, example linear temporal logic, to detect violations. Formal contracts, pre-post conditions invariants ensure that adaptations pursue system safety and liveness properties. Statistical model checking estimates the probability that a stochastic system satisfies a temporal logic property using Monte Carlo simulation. In assurance cases, example JSON or CAE provide structured arguments with evidence to justify system trustworthiness despite adoption. Fallback mechanisms and rollback strategies ensure safe operation when adaptation using checkpointing and redundant exception paths. Multi-agent coordination and emerges. In multi-agent coordination, mechanisms include negotiation, voting, and market-based auctions for resource allocation. In emergent behavior, arises from local interactions without centralized control, as seen in swarm robotics or flocking algorithms. Game theoretic approaches model strategic interactions using Nash equilibria or correlated equilibria to predict stable outcomes. Informal method adaptation logic in this diagram smart AI evolution, energy, away and resource concept adaptation. Agents optimize energy consumption, dynamic voltage or frequency scaling, or task offloading to edge cloud resources. Resource budget CPU memory bandwidth are modeled as constant in optimization problem solved by linear or integer programming. Utility functions trade off performance against resource usage V equal to alpha of performance minus beta of energy minus gamma of latency. Predictive adaptations uses forecasting models and anticipate resource demands or pre-allocate accordingly. Security and trust in adaptive systems. The secure multi-party computation in collaborative learning without exposing private agent data, trust models confident to other agents, cooperation, uncertain evidence. Case study and autonomous drone swarms. Drone swarms are decentralized control with local communication achieved to collective tasks like search and rescue or surveillance. A formation control lists and consists algorithms to maintain geometric patterns while avoiding collisions using potential fields. In energy where task allocation disturbs missions based on remaining battery and fight range using auction-based mechanisms. Could agents monitor service health using metrics like latency, error rates, and throughput to detect anomalies via statistical process control? Simulation and testing environments. Digital twins create virtual replicas and physical systems to operation in safe controlled environment. Ethical and societal implements. Verifying research challenges, future directions and emerging trends, summary and key takeaways. In the total entire PPT, what is summary and key takeaways means self-adaptive intelligent agents integrate perception, reasoning, learning, and action to operate autonomously in dynamic environments. Decision making and uncertainty relies in MDPs, POMDPS, and reinforcement learning to optimize long-term utility. Thank you.